For geometry lesson 6.4, this is not a difficult lesson, but it's a little bit confusing if you're not sure exactly what the difference is between a rhombus, a rectangle, and a square, because sometimes one can also be another one, but it can't work the other direction. So let's be sure you know exactly which is what. So these were supposed to be highlighted, but it's hard to see. So a rhombus, it's a parallelogram, meaning opposite sides are parallel, meaning opposite angles are congruent, meaning consecutive angles add up to 180. All of the things that are also a parallelogram. However, all four sides are congruent. So this side is the same length as this side is the same length as this side is the same length as this side. So that is what makes a rhombus. A rectangle is also a parallelogram, so all the same things happen with parallelograms happen with rectangles. The difference is all four angles are right angles. They all measure 90 degrees. Okay, and then lastly, a square has both. It has all four equal side lengths and all four angles measure 90 degrees. So therefore, a square is both a rectangle and a rhombus. But the things that make them specific to themselves are that the rhombus is just the four side lengths, has nothing to do with angles. The rectangle is just the 90-degree angles. We didn't say anything about what their side lengths have to be. It's just the opposite ones are equal to each other because that's the whole point of being a parallelogram. And then a square has 90-degree angles and all four side lengths the same. Okay, so number one, let's look down here at the practice. Number one, decide whether it's a rhombus, rectangle, or a square, what the best name for it would be. So these two are the same, but then opposite these two are the same. But all four have right angles. So the four having right angles and different side lengths is going to make this one a rectangle. All right. This one, we don't know anything about the angles. They're not marked up as 90, so we don't know if it's a square. All we know is that all four side lengths are the same, so therefore the best name for this shape is going to be a rhombus. All right, let's look at number 3. Again, definitely not 90-degree angles. You can see that. But all four side lengths are the same, so this is going to be a rhombus. And then lastly, number 4, all four side lengths measure the same. All four angles measure 90 degrees. This one is a square. Okay, here's a quick picture. Squares are both, we talked about that. Special parallelograms. Rhombuses have the same side lengths. Rectangles have 90-degree angles. And squares in this Venn diagram happen to be both. So that's a good mental picture for you to have. All right, let's turn the page and look at the theorems here. So the first one says, if a parallelogram is a rectangle, then its diagonals are congruent. So this AC is congruent to BD, just like it says here. So if it's a rectangle, then the diagonals are congruent to each other. Okay, let's do a little practice with that. If LN is 4x minus 17 and MO is, I shouldn't have written like that, but here, 2x plus 13, what are the lengths? So remember, they are congruent to each other. So I'm going to set it up 4x minus 17 is equal to 2x plus 13 because they're congruent to each other. So let's solve this. I'm going to minus 2x on both sides. 2x minus 17 is 13. I'm going to add 17 on both sides. This is 30. Divide both sides by 2. X would be equal to 15. So then it says, what are those lengths? So now I have to take my x equals 15 and go ahead and substitute 15 for x. And I could do it in both if I want, but really I just need to do it in one or the other because since they're congruent to each other, whatever one answer is the same as the other. So I'm going to plug it into this one down here. 2 times not x because it's 15 plus 13 that is 30 plus 13, which is 43. So x is 15 and 43 is the side lengths, or sorry, no, the diagonal lengths. Okay. Take a look down here at the next one. It says, what are the measures of each of the numbered angles in rectangle ABCD? So, if these two make equal angles, actually, I'm not sure that we have learned this part yet. This is actually in this theorem. So let's go on to the next page right now so we can talk about the next theorem. And then we can go back if we want and look at the angle measures. But we're going to actually see some more on this page. So sorry for skipping around, but let's move on to what a parallelogram. Okay, when it's a rhombus, so these are rhombuses, then its diagonals are perpendicular. So look, if this is a rhombus and all four side lengths are equal to each other, then if you draw diagonals in, their diagonals make 90-degree perpendicular angles. Okay, and then here's the other thing you should know. If it's a rhombus, these diagonals bisect the opposite angles. So that means it cuts 1 and 2 into two equal angles. 3 and 4 would be equal angles. 5 and 6 would be equal angles, and 7 and 8 would be equal angles. So rhombuses are really cool, rhombi, whatever, because they make 90-degree angles in the center for angles. All four of these would be right angles. And it also equally bisects these two angles and these two angles. So it's really a cool thing. Okay, so knowing that, let's look at the next problems. So this is a rhombus. If this is 104, this is 104, and if it cuts this equally in halves, then what that means is each side length is the same. And if each side length is the same, then each angle is the same. We know this is 104. You can do this a couple different ways. I think I would look at it as the left triangle. So let's just look at it like this. 1 and 3 are going to be equal to each other, and the other angle is 104. We know that triangles add up to 180. So I'm going to do 180 minus 104 and then cut it into two equal parts. So 180 minus 104 is 76, and I'm going to divide that in half and get 38 over here and 38 over here, which means this one's also 38, which means this one's also 38. Okay, let's look at this one. If this half is 58, then that means this half is also 58, which means this one is 58, which means this one is 58. We know that in a rhombus, all four of the center ones are 90, so angle 1 is 90 degrees. And if this is 90 and this is 58, then we can subtract from 180, 180 minus 90 minus 58. And we can see that 32 is going to be down here. And down here, not that it asked, but yes. Okay, and then let's go down to this LMNO. This is also, this says it's a square this time. So it's a square, which has the same properties as a rhombus because the side lengths are all the same. And its diagonals are going to form right angles. So 1 is 90, so 2 is 90. So 3 is going to be 45s because 90 plus 45 plus 45 splits equally into halves. Okay, let's look at the next page. This is where your practice starts. This is a good chance to push pause and actually try some of these on your own and then fast forward and see if you did these right. If you're not quite ready to try these on your own, I'm going to do these with you, but a little bit faster than normal. We've already done some like this. So equal side lengths means this one is a rhombus. Opposite side lengths and all 90-degree angles means this one is a rectangle. Both side lengths and 90-degree angles means this one is a square. And This one we only know one set of opposite side lengths and one set of parallel and only one angle. So this one is not enough information. So not enough information. All right, let's look down at number 5. Find the measures of the numbered angles in each rhombus. So they're telling us it's a rhombus. If this is 38, then this is also 38. All right, if this is 38 plus we don't know, it has to add up to 180. So I would do 38 plus 38, 76, 180 minus 76 is going to be 104, which means that 3 also has to be 104. Oh, I think the measure of angle 1 was 38. Okay, number 6, if this is 73, we need to subtract from 180 and divide it by 2. So 180 minus the 73 we have down here and divide it in half. Ooh, we're going to have a 0.5, 53.5. So 53.5 here, 53.5 here, 53.5 here, 53.5 here. And it didn't ask us for this one, but this one would be 73 because it's opposite angles, same thing as parallelograms. All right, number 7, 106. So number 1 would also be 106. If we subtract from 180 and cut them in halves, 180 minus 106 is 74. Divided by 2 means each of these is 37, 37, 37, 37. Okay, number 8. All of the centers are 90 degrees, so the measure of angle 2 equals 90 degrees. And if we know that one's 90, well, actually all 4 of these would be 90. Let's do it like this. If this is 70, this would also be 70. That means 3 would also be 70, and this one up here would also be 70. So if we have 90, 70, and we don't know, let's subtract it from 180. So 180 minus 90 minus 70, it means 20 degrees are these tiny little ones down here. All right, number 9. 1 is 90. I'm just going to make a little box around it. If this one is 25, then this one is also 25, then this one is 25, and this one is 25. 90 plus 25 plus we don't know. So number 2 is 90, 25, and question mark equals 180. So 180 minus 90 minus 25 is 65. So angle 2 is going to be 65, which means angle 3 is also going to be 65. All right, number 10. These are all 90. So angle 2 is 90 degrees. If this is 52, then this is 52. And then we're going to have to subtract 90 and 52 to come up with what 3 is. So 180 minus 90 minus 52 is 38. So 3 would be 38, this one would be 38, this one would be 38, and this one would be 38. All right, let's take a look at the next page. There's a little bit of algebra involved here. I'm not going to go through and do all of these because you guys are going to have some of these to practice on your own, but let's just make sure you understand them. If it doesn't give you a picture, but it says QRST is a rectangle, find the value of x and the length of each diagonal. So I'm just going to draw a quick picture. QRST, and they're saying it's a rectangle. From Q to S is x. And R to T is 6x minus 10. It's hard to see, but these are equal to each other in rectangles. So I would set, RT 5. I'm not sure if that was supposed to be like this. Let's skip 11 because I'm not sure where the 5 is coming from. And that's a little confusing. So otherwise I would have just set them equal to each other. Down here, you have QS and RT. So these are equal to each other. So since those are the diagonals, so you would set up for x minus 7, I'm looking at number 12, equal to 2x plus 11, and you would go ahead and solve that to find x. That is basically the same thing as all of these are. They're just giving you different amounts to practice setting it up like this. So let's skip down to 16. The most precise name for number 16 is going to be a rhombus. And that's because it doesn't say anything about 90-degree angles. All we know is that all 4 side lengths are the same. The most precise name for 17 is going to also be a rhombus. And the reason is because we don't know that all 4 are 90-degree angles. We just know if opposite sides are parallel, then that means opposite angles are congruent. But we don't know the other opposite ones for sure. I could see an argument for it though, for square. In fact, if you know that these are opposite and these are opposite and they're all the same length, I think we actually can assume that it's going to be a square. So actually, I think that's the better name for it. All right, 18 opposite side lengths are equal. 90 degrees here, that would be also here. And again, if opposite sides are parallel, you can subtract the 2 90 degrees. That would mean this is a rectangle. All right, and then the last one, definitely all 4 same side lengths, which makes it a rhombus. Okay, number 20, we are going to write true or false. If it's false, rewrite it to make it true. Rhombuses, I think it's supposed to be rhombi, but that's okay. Rhombuses have 4 congruent sides. True. Number 21, rectangles have 4 congruent angles. Also true. They have to be 90 degrees, but they are congruent. Number 22, the diagonals of a rectangle bisect the opposite angles. This would be the diagonals of rectangles. The diagonals of rectangles. Let's look back and make sure. Diagonals of rectangles are congruent to each other, but don't necessarily bisect each other. The ones that bisect each other are rhombuses. So the diagonals of not rectangles, but of rhombuses. Rhombuses. I really thought it was rhombi, but that's okay. All right, and then the last one, the diagonals of rhombuses are always congruent. That is rectangles, the diagonals of rectangles. So again, these were false to begin with, but then we corrected them. Okay, 24 and 25 are just more algebra practice. Opposite side lengths are equal to each other. Opposite side lengths are equal to each other. Oh, actually, in a square, all 4 side lengths are equal to each other. But in a rhombus, also all 4 side lengths are equal to each other. So if you'd like, take a minute to solve for x and y.